One does not simply learn Git. This is a true statement. I mean, Git is complicated and has a lot of functionality as one of the leading version control systems out there, which could be confusing at times. But also there are so many useful features in Git that if we grasp and master, it will accelerate your growth as a programmer. In this video, we will attempt to do so by going over some Git commands that will improve the quality of your life once you start understanding and start incorporating them into your workflow. To overview, we're going to go over 5 Git commands: the Git Log, Git Stash, Git Diff, Git Reset, and Git Revert. And we're going to demonstrate some examples of how these commands actually work. Let's get to it. Alright, Git Logs. Git Logs are very straightforward. It shows you the commit history of a particular branch. You can run that command in the terminal, git log, and it prints out essentially what all the commits are within this branch. So this is descending order, so this top commit is the most recent commit, and this is the previous commit. So initially, there's a commit here, and then I added the functionality and added another commit. The commit shows you who the commit was made by, the email associated with that user, and the date of the commit, along with the commit message at the body here. On the right hand side, Git Bash in Windows by default shows you some branch information. So it shows you the head position locally, which is right here, which is the branch. So these green branches indicate your local branch, and the red branches indicate the remote branch. You can see the remote branch and the local branch are on the same commit. And it shows you the master information here as well. So that's essentially the basics of logs. So it's very useful if you want to see the history, who made the commits, when, and what sort of commit was made. For VS Code specifically, there's a great plugin called the Git History plugin. So go navigate to the left side in your extensions menu, search for Git History. And the first one by Don Jayaman. This extension is very useful in looking at the Git history for a particular file. So install it, and once it's completed installing, you can actually open up the window by pressing this button on the top right, Git View File History, or Alt-H. And now, if I actually zoom out to make this look a little bit better, there we go. To actually zoom out, you can see for this particular file, the Git history associated with it. So in this file specifically, this was added with this commit. So just to illustrate the point, let's say I added some changes into my file. So console.log and then change 1. And let me actually commit this. Let me actually redo that. So index, and then I'm going to add some changes in here. ASDF, for example. And I'm going to add that. And I'm going to commit. Now, as you can see, the commit has been made. So if I do a git log again, it's going to show you the new commit here is at the top. So my branch position, now my head is one step ahead, or one commit ahead of the remote repository. And you can actually verify that by running git status, which will show you that your branch indeed is ahead of the remote repository by one commit. And if you open this up in the Git history extension, you can see that, let's try opening up that again. Oh, that's Alt-H is the hotkey. So yeah, as you can see, the first commit is being updated now. So this tool is very useful. Like, it has a lot of different functionalities. So go ahead and just take your time to kind of learn about it. You can filter it through. You can switch over to different branches and see how this file changed over time in different branches. One of the features I really like is this previous function right here. So if you actually look on the right side, you can click on a commit and compare it to the previous commit. So if I compare it, it actually shows you side by side what has been changed. And in this case, because of the commit I made, you can see that I added this console.log. So yeah, Git log is very helpful for troubleshooting, and just seeing your commit history and just trying to figure out what happened to this code. Especially if there's multiple developers working on it, this is extremely helpful. Oh, just one note. So in Git log, if your Git log is long, you see the semicolon at the bottom here. You can navigate through with your down arrow, up arrow, And to escape this, you can just press the Q button, the Q key, and you press Q, you return to your terminal. Git Stash. Git Stash is truly a life-changing command for Git if you actually incorporate it into your workflow. So essentially, Git Stash gives you the ability to store your temporary dirty changes temporarily, and then allows you to retrieve them at a later time. So this is very useful, for example, if you want to revert your branch to the starting position, and then you want to just run some tests and then revert it back with all your changes. It's also useful for when you want to switch around between different branches. So let's go over what Stash actually does. So we have a clean working tree here. Let me make a change here. I'm gonna console log ASDF. Now we have 2 console logs. So if I do a status here, it's gonna see that there is a change in the working tree. Now, if I stash this change by running the git stash command without any parameters, it's gonna actually stash all my dirty changes that we had, and it's gonna revert this back to what we originally had. So if you do a git status, for example, look, it's clean and there's nothing to commit. And you can replay this by running, or actually you can pop it back into your project by running git stash apply or git stash pop. And once you pop it, your changes are now played back onto this file, and if you do a git status, you'll see indeed that you know there's a change in your file. So what happens when you actually stash stuff? Let's take a deeper dive here. So originally, working tree, add a change, and then once you have a dirty tree, you can actually stash this. Once you stash it, if you do a git stash list, it'll list you all the different stashes that you have made during the session. So in this case, you know, we have 3 here, but these were the 2 previous stash that we had, and this is the stash that I just pushed into the stash. So let me clear this actually, and just to make it a little bit more visually appealing. ASDF, I made a change, I stashed my change, or let's do a git stash list. So list, there's nothing. Now I git stash push, or just git stash actually, and then if I do a git stash list, my changes all have been temporarily stored in this stash at the 0 position. I'm gonna make another change. Let's call it the second change. If I push this into my stash again, and then I do a git stash list, you'll see that the 0 position has now been updated. It's a little hard to see here because the names are the same. So what I like to do when I stash is to give it some sort of message. So let's clear this and start from the very beginning. Console.log ASDF, and then I'm gonna stash my change. Git stash push, and then with a message flag, first stash. Now my changes have been pushed into stash, and then if I do a git stash list, it'll show you. There we go. That's my first stash. Now let's do a second stash. So console.log. This is the second stash. So there, that's my dirty change right there. So I'm gonna stash that change out of the project. Git stash push and second stash. Now, if you do a git stash list, you're gonna actually see the second stash is on top at the 0 position of the first stash. So when you pop something out of stash, it actually pops the 0 index first, the top level stash first. So if I stash pop this, it's gonna pop the 0 index. Git stash pop, there we go, and you see the second stash change has been played back onto my file. Now, if you do a git stash list again, you see that the first stash is now in the 0 position. It moved up one index. So if I actually do a git stash pop here, it's not gonna work because it conflicts. But if I just remove that and I pop it again, There we go. We see the first change. The first stash has been played on the file now. And when you do git stash list here, your stash list is empty because you popped both stashes out of it. So this is very, very useful in the case that you want to revert your branch. So let's say you were adding some feature here. You know, you added a function, and then at this point something's not working, and then you're pulling your hair out, and then you want to revert back to the original branch, right? You want to get it back to where it was working. You just literally just stash this, and then it reverts it back. So your working tree is clean, and then the commit you're on is, if you do git log, your commit is what you started with. Another useful feature of this is if you want to switch branches. So let me just git stash pop the first element. So let's just say, you know, you're working on your feature, and then your boss tells you, hey, there's a red alert in production. Could you take a look at it, please? This is urgent. Then you're working on this feature, and you're not complete yet, and you don't want to commit these changes, but you want to come back to this after you resolve the priority items first. So what you would do is you would stash your changes, and then, oh, actually, let me show you the case where you can't actually switch branches. So let me just pop the changes. Git stash pop. So you made your changes, you added this function. So you want to check out the master branch to address that red alert that your boss just told you about. But then you can't actually switch to the master branch because this has been changed, and there's a change and it aborts the switch or the checkout. So what you do is here, you temporarily save all your changes into stash. You check out the master branch or whatever branch you need to. Now it allows you to change it because there's no conflicts. And then once you're in the master branch, you do whatever you need to do, resolve the issue, and at a later point in time, you want to start working on your feature again. So you check out to this branch that you were working on, and you essentially stash pop whatever you're working on. Now, all your changes that you made, the functions that you added, the console logs that you added, has been played back onto your file, and on this point on, you can continue your development. So you see the seamless transition. You can switch branches whenever you want using Git Stash. Git Stash has a lot of different functionalities. So you can actually, you know, like I said, you can Git Stash M. You can pass in a message whenever you stash it. You can actually pop. By default, when you run pop, it pops out the 0 index first. But let me show you an example where you can pop out different indexes in different orders. So here, let me add console log, first change. So I'm going to stash this change first. Git stash. Let's give it a name. Push this change as a first change. Now git stash list. So it has been pushed. And let's say I make a change in the config file. So is human. Let's just add an entry in there. So you can stash this change as well. So the config change has been made, indicated by here. Now we're gonna git stash. We're gonna push with another message. This is the second change in config. Now do a git stash list. You'll see the first change is in the 1 position. The second change is in the 0 position. So by default, if I do a git stash pop here, it's gonna pop out the most recently pushed change. Well, let's just say I wanted to pop out this first, the stash 1 first. What you can do is git stash pop and then pass in the index flag with the following index that you want to actually pop out, which in this case is 1. So now, as you can see, the first change has been popped out of the stash, and the second one still exists. And this git stash apply actually is an alias for git stash pop. So I popped the first change and I popped the second change. And actually, if you actually see the config file, there you go. You see both of my changes. So you can do these all independently. Also, one thing to note, usually when you do a stash, it will take all the changes in your file. So we had 2 changes in 2 files, it stashed all of your change into a single stash, as you can see, which is this one right here. But you can actually stash individual files as well. So let me just demonstrate that for you. So let me add, sorry, git stash list is empty. Let me just verify is human is true. So we're gonna stash this file, and let me just add here. This is my second change. So if you actually print out the status, you're gonna see 2 changes here. So let me actually stash this first, and then stash this second. Git stash push, give it a message, stashing config only. And then you pass in the file name that you want to stash. So if you do that, do git status, you see that the config file has been reverted. So my changes are gone, but the index.js still has this change. So I just demonstrated how you can stash single files. And you can do the same thing with the second one. You can just do git stash push with the message, index.js stash single file. And then you would pass in the file path or the file name, index.js. There we go. Now both of our changes are in stash, and if you do git stash list, you see that indeed it both exists in the stash. And you can pop these independently. Git stash pop, git stash pop. Now all of your changes have been played back in your project, and then you can just continue your development. So stash is very powerful. It's very, very useful if you actually start incorporating this into your workflow. Like I said, you can switch branches whenever you want without losing your changes. You know, if you're not happy with the feature that you developed, you can just throw away all your changes by stashing everything and then starting from scratch. So yeah, that's Git stashes. Just keep practicing, just use it, start using it, and then it'll be very helpful, I guarantee. Git Diff. Okay, so Git Diff is very useful if you want to compare the changes that you made to what the commit is on. So for example, I'm gonna do a git status to show you that this working tree is actually clean, so there are no dirty changes. Let me introduce some changes. So let's add a function here, my function. This is my function. So I added a change there, and let's add a change to the configuration. Are you human? And then let's say yes, I am indeed human. And let's make a change here as well in the main entry file. Let's just add a comment saying hello to Groot. Now, if you do git status, you're going to see that the working tree is indeed dirty because I made modifications to the code. Now, in order to see what those changes, so in this case, it's very simple, right? We can just keep track of it because it's literally just single line changes in these 2 files. But let's just say you have a huge function that you added and you want to see what the diff is. You want to see the difference between the change you made and what the commit is currently. If you run the git diff command here, GitHub actually shows you the differences. So here, you walk through, you'll see, you know, in the config file, we added this line item. In the human interactions file, we added a new function. And in the config file, we added this new line. And you can keep going down. So exit that by pressing the Q. So that is very helpful. But as you can see, this is not the most UI friendly way of viewing the differences. So if you are a VS Code user, VS Code by default ships with this tool on the left hand side, source control. If you actually click that button, so VS Code actually interprets Git and shows you all of this in the UI. So for example, if I click on this change item or in this config.js, you can actually see, oh, this is a change. And then index.js, Okay, so there's some formatting changes going on here, and I added a comment here. The human interactions. Cool, I added a function. So as you can see, this diff tool, this VS Code diff tool is very powerful. I really like using this diff tool in VS Code, so I would recommend if you are a VS Code user to use this tool. But there are many different diff tools out there, and you can actually define a custom diff tool. So let's just say you found like a diff tool that you really like. Then you can define that in your config parameters. So in the config, by default, in your home directory, there's a .config file, and in here it contains all of your global configurations. So you can actually add a diff tool and give that tool path, and whenever you do a git diff, it's actually going to open that. So we might create a video kind of going over different diff tools and comparing different diff tools and seeing the pros and cons of each, but we'll do that another time. But just letting you know that that option is out there, so you don't have to rely on VS Code, and even if you're not using VS Code, there's other ways out there to incorporate different tools into your workflow. So yeah, git diff, that's pretty much it. That shows you what git diff is. Usually, when you commit, you would verify this git diff. You would verify in the diff, make sure that your changes are all good to go. And once you verified it, you'll say, all right, let's add our files and let's commit. The Git verification tool. That's it for diff. Git reset, especially the infamous git reset -- hard. So let's talk about git reset, so what it is. So git reset essentially is a way to revert your code back to a previous commit whenever you make a mistake. So for example, in this case, let me just do a git log here. I have several commits here. I have the most recent commit right here. Made a commit here, made a commit here. But let's say I wasn't happy with these two commits, or I committed them by mistake, and I want to revert these changes back. The way to do that is to use a git reset command. And by default, when you run it locally, let's try it. So git reset. You actually run the git reset command by passing in the commit SHA, which is right here. So I'm just gonna copy paste this, and then I'm gonna reset the commit back to, I'm gonna reset my local branch back to what it originally was. So I can run this command, git reset, and pass the SHA. You can pass the full SHA in, or you can pass just part of the SHA. Git is smart enough to know exactly which SHA you're referring to. So let's try this. I'm gonna reset it. Now, what happens? When you reset your commit, you see that there's some dirty changes that it's still keeping. So if I do a git log, you're gonna see that the two commits that we saw previously have been removed, and the head is now back to the original position of where it was when we first checked out this branch. But the changes are actually kept as dirty changes. So that's very helpful, right? So let's just say we made some mistake in our commit. By git resetting, we can revert our commit back, but we can keep our changes. So if I look at index.js, this is the function that I added. You can actually see that. So git diff on that specific file, for example. So yeah, you'll see that this is a difference. So this is the change that I made, and I kept it. So from here, if there was a problem with your function, you can fix the function. And then once you're happy with the changes or in the configuration, oh no, this was not correct, it's false, I'm not human. Then you can change it back. You can change the index. You can just remove this comment. And now you can do another commit to fix all of your mistakes. Or git add. And then you can do a git commit. Refixed or fixed my commit. So once you commit that and you do a git log, you'll see the commit is here, and this was the previous commit. So the two commits that you made earlier, they're completely gone, and they're gone from the git history, and you won't see them anywhere. So that wasn't so bad, right? But one of the dangers of git reset is when you do a reset hard. So in the same history, let's say I'm going to remove the commit I just made, which is this ff2d41. I'm going to copy paste this commit, SHA, and I'm going to git reset, but instead now I'm going to pass in the hard flag and then pass in the SHA. Now let's see what happens here. So for the git log ff82, oh great, this is what I wanted to. Oh no, that's not the correct commit that I want to revert. I want to revert to 7cdd, what I originally checked out to. So let's start that again. So I'm going to do git reset hard to original commit. Now if you do git log, okay, I'm back at 7cdd. Now if I do git status here though, my working tree is clean, which doesn't make sense because I just made some changes. But if I look at my index.js, all my changes have been deleted. Remember I had are you human here? So that's gone. And in index.js I had my new function and that's gone. And that is the danger of using git reset hard. It actually reverts your code to exactly what the commit is. And that's the danger of resetting hard, especially commits that you didn't work on. Because you have the potential to lose changes that other people have made. So when you run git reset, especially when you're doing git reset hard, always keep in mind, am I destroying anything? Because this is a destructive process and you can lose all of your hard work, it is a dangerous command to use. But if you know what you're doing, you know, you can use it when you need to. Normally, I don't like using git reset hard. Git provides another reversion tool or command called git revert, which we'll go over in a bit. So that's my preferred way of reverting changes because you still keep the history of all the changes in your commit. The git reset actually removes commits from your git history, which is a destructive process, and if it's not used carefully, you could ruin a project and you can ruin other people's lives. That being said, you know, git reset's not too bad. I hope that was helpful. I think I covered most everything, or the basics of git reset. Just keep in mind when you do a git reset hard, think twice. Double think again, and make sure that nothing is being destroyed. And just be aware when you do a git reset, it doesn't automatically push to the remote repository or something. All these changes are local until you do a push. So keep that in mind. When you push, keep in mind if you haven't destroyed anything, if you haven't removed any commits. It's all good and fun locally, but if you push it remotely and affect other people, then there could be potential problems in the future. So yeah, that's the gist of using git reset. Hopefully that wasn't too bad, and hopefully you can start using it when you need to. Thank you. Alright, so we just looked at git reset, especially the -- hard flag, and just emphasized how it was a destructive process of reverting our code back to our previous commit. Git provides you with another command called git revert, which is a safer way to revert your code to a previous commit because it doesn't actually delete or remove your git or your commits from the git history. It actually adds another commit that provides you with all the changes to revert to the specific code. So let's demonstrate that here and see how we can use git revert to safely revert our code back to a previous state. So for example, let's do git status. I have a clean working tree. I'm going to add a function here. Incorrect function. So I made some changes. I added this weird function. And let's say either out of mistake, I committed this change. So git add. And then I committed this bad function. Now, if I actually do git log, you'll see that the commit indeed has been made. 44027, and it's a bad function. Now I want to get back to 7cdd39. I want to get back to what I checked out to. So like I mentioned in the previous video, we could use a git reset, but also the more safer way, let's just say this code was actually pushed to the remote repository, but I don't want to do a git reset hard and then push. I want to do this the safer way. In order to do that, you copy paste, or you get the SHA of the commit that you want to get rid of. So in this case, this is the bad commit I want to revert. You can copy paste this and pass it into the command git revert your bad commit. And once you revert it, it's gonna give you this, it's gonna open up, and then you can give this commit a message. So this reverse commit 44027, you can add whatever you need to. This was an incorrect merge or incorrect commit. I don't want this. Now that is your commit message. So essentially what revert does is creates a new commit and then reverts your code changes back to what you need to the commit that was previous. So let's just demonstrate that. It's just a little more clear when I actually go through the process. So I added my message and I'm going to close this. Now the commit has been made. And if I go to Git Log, you'll see this is the original commit that I wanted to revert back to. This is the bad commit I made. And this is the revert commit that was just made by that revert command, and it has the message. So this reverts commit 4427, and then this is an incorrect. This is the message that I added. So when it reverts to 4427, it goes to the previous commit of the bad commit. So now my code is based off of this commit. So essentially the 5f9b, this revert commit, in terms of code, is exactly the same code as what it was down here. And you can verify that by looking at the code. So I added the function here. Remember the bad function? But that bad function is now gone. So that's how you revert your code safely. So this is safe because it leaves a trail. When you open up the history by opening up Git Log, you see exactly what happened. The timeline doesn't change. So 7cdd here, I made a commit, I reverted the commit. And other developers are able to see this as well if you push this upstream. And then they'll know exactly what happened and say, oh, hey, you made a bad one here. Gotcha, I see what you did here. So you see how this is useful and is a much safer way to revert your code changes. It doesn't delete any timeline like git reset -- hard or git reset. And it just leaves a trail, and you can add comments to let other people know exactly what is going on. So this is my preferred method of reverting code changes. And hopefully you won't have to use revert, but while you're developing, mistakes can happen, or there are some commits that you didn't want to push, but you did. And this is a good way of reverting and then rectifying the situation. Just to add one more thing, I want to talk about how to revert multiple commits. So let's say instead of one commit that you wanted to revert, let's say you made a series of bad commits. You were just having a bad day, and then you want to revert multiple commits. Let's demonstrate that here. So this is a clean working tree. So let's say I'm going to introduce some bad commits here. Bad commit 1. So let's say I made that. And then I'm going to add, and I'm going to commit that. Now bad commit 1 has been made. Now let's just say I added another error. Bad commit 2. Now let's add that again, and then commit the bad commit. Let's just add another one. Bad commit 3. git add, and then git commit, bad commit 3. So at this point, for the git log, you'll see that I have these 3 bad commits that I want to revert. But we don't want to use the reset function or the reset command. Let's say I want to do this safely and use the revert command. The way to do that is to revert each bad commit. So in our case, 7fdd, b62, and 6e9. These are the 3 commits that I want to revert. So I'm just gonna copy paste these commits just so I don't forget. So that's the first one, that's the second one, that's the third one. And you can commit, or you can revert the commits individually and then have a single commit message. And let's demonstrate that. So I'm going to git revert the first one, the topmost one, no commit, and then this is indeed the topmost one. So I'm going to revert the most recent one first. There we go. It reverted the first one. Now, we don't see a commit for that because we passed in that no commit flag. But it's the commit is still, the changes are still saved. As you can see here, now the status of this branch is reverting. So you'll see when you do a git status, you're currently reverting commit 75dd fe1. Now let's revert the additional 2 bad commits. So same process, git revert, no commit, and then pass in the second revert, or the second SHA that you want to revert. So now it adds on top of your already existing revert the second commit. Now you want to do that with the third commit that you just made. Git revert, no commit, and we add the third SHA. Now at this point we're done. So we committed all 3 SHAs that we want to revert. And from here we can end this revert by passing in, or by entering this command, git commit m reverting all 3 bad commits. Sorry. Now once that commit is made, you'll see that there's a single commit here, fc838. So this is now the revert commit that's reverting all 3 of these bad commits here. So at this point, your code is going to reflect the code that's in 7cdd39e9. And you can verify that by looking at the index.js. Remember how we had the console logs? Bad commit 1, bad commit 2, bad commit 3. As you can see, those are all removed. So now your code is good to go. Your code has been reverted properly, and then we've collected all of the reversions into a single revert commit. And that's how you would revert multiple commits. And the history is still, the timeline doesn't change, and other developers can see it and make sense of the Git log. So yeah, hopefully that was helpful. Hopefully, you don't have to get to this point of reverting multiple commits, because it does get, kind of complicated if there's multiple commits. But that is a way to do it, and hopefully it's helpful for you in whatever situation you're in. Thank you. Thank you for tuning in, guys. Alright, if you guys enjoyed that video, please like, comment, and subscribe. Like, comment, and subscribe. Like, comment, and subscribe. Wait, how come I'm doing this? Like, comment, and subscribe. Like, comment. Okay, I'm done.